At a project that has Spring App, and we're looking at the environments section so we can see the different environments that are set up that we're working with. We have several that are not deployed to yet, but that are running runners, which is our agent, on bare metal servers, VMs on EC2, my Mac laptop, and VMs on hard metal, straight to the metal. Now, if you want to see the details of what is available for that, you can look at the documentation that has a listing of all the different platforms that we can run on, that is deploy to and use to run processes. Now, there's two other environments here that we want to point out. One is staging, one is production. There's actually three. There's a whole bunch of them four of them under the review folder here. And those are dynamic environments that get spun up per commit so that a developer can check their changes in a real running app and allow their stakeholders to interact with their changes as well. Those are ephemeral. Let's take a look at production and staging, because those are actually set up in the cloud with Kubernetes. So our Kubernetes setting is using both, for production environment, we're using an EKS cluster in AWS. And the catch-all for everything else, so the review apps and the staging app, are going to be created in the GCP cluster, Google, on their GKE Kubernetes in the cloud. So real quick, just to kind of see how this plays out, we actually have built-in monitoring once you have it integrated in of that cluster. Once you're connected, we can install lots of utilities that add capability around allowing Git Lab to manage the cloud installation for you. But here's what we want to look at. I'm going to take a look at the endpoint here so we can see what we're running on, CFDB, etc. And that is this Amazon cluster here. So the endpoint again, CFDB. And in order to take a look at that, we will make sure, first of all, that we are pointed to the right cluster. So the current context does have us pointing to the AWS cluster. And what we'll do is we will do a kubectl get pods and all namespaces. So what we'll see is everything that's installed on this cluster. You can see there's the apps that were installed by GitLab to help manage the cluster and add functionality. This is the kube system processes and containers. And then here is the Spring app, which is, again, that is our application. So this is a namespace named after our application. And you can see that there are 5 production apps. The first one beginning with 5Z297. So if we go back and take a look at our environments, which are right here, we can see that we have under production 1, 2, 3, 4, 5, and the first one is 5Z297. So this is our cloud support in EKS and GKE showing up throughout the system. You saw monitoring. We saw that our environments are supporting using those cloud environments. GitLab releases, which is a relatively new functionality. We have links to the changelog. In this case, there's only one, and this lets us get to the information. In this case, an issue about what has gone into the release. So here is the issue that is that's part of this release. We can see that it has a related merge request because the work was completed. So now we have traceability from the release all the way through to the production of that release. And so here we see the pipeline that built it, as well as all of the information. It was deployed to a review app so we could check it out before we committed it to our default code base, and as well as to production. We can see code quality and security information from the scans and licensing information. And this was merged because the person reviewed it and decided that it was good to go. It automatically closed that issue so that we have that tracking taken care of for us. And then went ahead and started the continuous delivery pipeline to bring that first to staging, and then on manual release all the way into production. So we see here that production has now the latest bit, and that is the release. Show you the blue-green deployment capabilities with Git Lab. So we're looking here at a set of environments that are in the Ruby app project, very simple app, and this is the result of developing and deploying blue-green to these environments. So what we'll see is if we look at the production blue environment, it's actually got this yellow, the first version, yellow, no version numbering. Then in staging and also we got a version 1, so we've incremented or iterated. And then in production green, which is currently our latest one, we have version 1 as well. So that means it's blue's turn to get the new stuff. So we're going to go ahead and make a change to our file. And in this case, we're going to do a quick edit. We will change the color to blue so it's more obvious. And we'll make that a little less painful, and we'll make that version 2. Now, since we're blue, we're going to also change the color to white so that it shows up, and then that's it. Those simple changes, some color tweaks, and we'll go ahead and commit those changes. Because I'm committing straight to master for the purpose of just timing on this demo, we're going to go ahead and see the production pipeline come up. So if I take a look at our pipelines, we should see that a new pipeline has been kicked off, and this is going to be one that rolls us all the way into production. So we see here it's going to do a series of tests that are defined in our pipeline file. It's going to build the docs, it's going to go to staging, and then after staging, it's going to wait for a manual deployment to the blue, green, on-prem, or playbook deploy. And so we're going to go to the blue environment. Okay, so now we have the pipeline completed. It started with build, took it all the way through, and is manually waiting for us to pick an environment. We're going to go to the blue environment at this point because we've already it is the next one to be new, and that deployment will happen. We can see the details if we so choose. We can go back and take another look at these environments, and we should see that again, the production green is at the yellow version 1, and the production blue is at the blue version 2. So now it's the latest, and the next time we do this, we will switch and go to the green environment and leave blue alone in case we need to jump back to it, or have it be the next one to go forward. Let me show you a little bit about the files that make that up. So if we look into the repository, take a peek at the ci.yaml file. This is how we define the behavior of the pipeline. We can see that we're going to do build. These are the stages: build, test, doc, review, staging, production, and cleanup. And in production is where we have multiple things defined. We have a blue part of production, which is a manual, and is going to go to the production blue environment. Green, likewise, that will go to the production green environment. You notice also the URL for getting to them is also amended to represent their stature. And then we also have some other capabilities here as well, like on-prem and staging and the review docs. So that is how it's defined. GitLab supports the use and management of feature flags. Feature flags enable developers to turn on and off capability in their code after deployment. So when a developer instruments their code with feature flags, like the Unleashed library, which we use, then after deployment, they can use the control panel to turn off and on capabilities. So here, for example, we have Tanuki logo, and this is currently active. That was instrumented in our Hello controller application. Here that application is running, and we're seeing the Tanuki logo. If I now go into the feature flags and I toggle off that functionality, and then simply reload the page, we see now that that capability is gone. Coming back again, I can toggle that feature on, which can be done for different environments and eventually different cohorts of people, so that different folks and different installations with the same code at different times can see different behavior without redeploying and changing the main code. Right, we're going to be looking at doing complex deployments using Git Lab. Rather than putting something together, we thought it would be really cool to actually show some work that a customer has done around this area. Flockademic, they have made this available publicly, and this is actually their real work with how they use GitLab to do complex deployments. So let's take a look. We'll take a look first at the pipeline itself, and then we'll hop into the CI/YAML file to get a sense for what they're doing in there. So we can see that they got a multi-step and multi-component application that they're deploying. They're doing preparation by running through the different components, the front end, the accounts, the periodicals, the server, and preparing those for deployment or build and deployment. They're doing tests to validate that those are all ready to go, the front end, the periodicals, etc. So again, multiple components, and those are running in parallel. And then when all of those finish in parallel, then they kick off a building of the back end. Again, the different components, accounts, and periodicals, and server, and then Terraform, which they're going to use to do deployment. Now, once those are complete once again, they go and do a deployment using Terraform. Terraform defines and executes on how to deploy their application into Kubernetes environment. With that backend complete, deployment complete, they then provision the backend databases, make sure those are hooked up appropriately and have seeded data properly, and then they build the front end, and then deploy the front end. I believe that's on Amazon. We'll take a look at that in a minute. And then they do a bunch of confidence checks, or so tests, basically, performance and license management, and looks like browser testing, and DAST and SAST, which are components that they're using from our library. So very cool. Pretty big set of components here getting laid out. Let's go ahead and take a look at their CI/YAML file. So this is actually what's running it. This is the definition of that pipeline. And what we can see here is first we're defining multiple stages. And within the stage, you can have multiple jobs. Those are the ones that run in parallel. So under the prepare stage, they're running the prepare job, the prepare front-end job, again in the prepare stage, the prepare server job. Looks like they're collecting work in progress commits. And if they see any of those, then they throw up a flag. They prepare accounts. Again, all similar type of thing there. And then once all the preparation is done, they start their test sequences. So the stage is test. They have a test and a test front end and a test accounts. And they're doing different tests of their different components here, test periodicals. And then they use Terraform to start, or actually when they build Terraform. This is called build Terraform and the build backend stage. Dummy job to preserve artifacts for undeployed job. Okay. And they build the server, they build accounts, and these are actually not dummy jobs, they are actually preparing and then running builds, yarn run build. And then using Terraform to do the deployment, deploying using a Terraform container, or image rather. They're defining here the different variables and scripts, or the variables that get used in the deployment sequence. And they're pushing to Heroku. And collecting their artifacts. They have a stop Terraform option that you can that can be taken manually. And this is what you would do if this was what would execute if that was done. So here's the definition of why it was that makes it manual. And this is to the review environments. Then they provision the database once the Terraform work is done there. Dependency is deploying Terraform, so you can define dependencies, do some Postgres work, and they build the front end, which then triggers deploying the front end. Once it's deployed, you'll note that they're actually deploying into Amazon, using Amazon keys here, that they are keeping in the CI variables so that they are protected secret keys and will only be passed into the script when it's running, and will be masked from logs so that nobody sees them. So deploying the front end, and then starting their confidence checks, which is the stage that kicks off things like the Firefox job and the Chrome job and DAST. And you'll see again they're using this component that we've provided, which is part of our auto DevOps, which is now composable so that other pieces can be pulled in to other pipelines. Browser performance test, again, that's coming from our auto DevOps pipeline, which has been made available for everybody to use components from. And there you have it. Pretty complex deployment being done by a customer using GitLab CI/CD. Okay, so while GitLab does have the notion of releases, which holds information about a release that has happened, we don't yet have the ability to define a release ahead of schedule and then schedule when it is going to happen. At this point in time, the way you would do that is to schedule a pipeline, because the pipelines are what drive the releases right now. So when a pipeline runs, it is continuous delivery, and if it's set to that, then it will push out code into production, and you can configure it to then create release information, such as what you're seeing here. So the way to schedule a pipeline is to go down to CI/CD and go to Schedules. In that, we can create a new schedule. We can call it whatever we want. Right, for example, release version 0.2. We can have it, let's use a cron to give a custom date for that. This would be at a given time and day. We leave it in the UTC time zone, sure. Define the branch that we're going to pull from. Some folks do release branches. We recommend doing feature branches or even shorter lived branches than that. But eventually when you do a release, after everything is built, you're going to want to do that off of your master branch or off of the one where you've consolidated whatever the default branch is, wherever you consolidate all of the work that's being done. In our case, that's master. And then just like with any pipeline invocations, you can define variables that can help the pipeline along or give it information about how it runs. And that is a standard piece of running a pipeline. So it would capture that information and use that. And then we would have it be active because we want this to actually happen, and then save the pipeline schedule. And there you have it. We have scheduled a pipeline run, which will result in a release. About modifying pipeline mid-flight as it's going, as well as take a look at the componentization and how the pipeline can be assembled from parts that are made available, and how we have definition of pipeline that suggests flow and actually adapts itself based on what it is seeing it is building and working with. So let's start here in this account. We're going to take a look at the GitLab.ci YAML file. This is the file that defines the pipeline. This particular pipeline is actually our auto DevOps built-in pipeline, but it's a good example. So you see that we have variables that can be defined in the beginning of the pipeline definition, but these can also be defined in the project level, at the CI project level, as well as during the invocation of the pipeline, so that you can have instance variables change and affect the pipeline based on what you need to do at that given time. So for example, we see that there's many stages here, but not all of them get run all the time. This build stage is set with the only tag or flag, which means that it will only run on branches and on tags. So when it kicks off, it looks at what it's working with and then makes a decision based on that on what needs to run and what doesn't. We see the same thing with test, and there's an except if the variable says test disabled. So this is an example of one of those variables, and there's a lot of them that you can define, again, either in this file or at the pipeline invocation or in the project level. So for example, if you never wanted to run the tests in your project, you could set that as a variable at a project level, and the pipeline would never run tests. Of course, when it runs, it captures all the information about what it's running with so that we have that and is known. If we keep looking through this, we see that pattern repeated a lot where we say only on branches and tags except some variable that would turn off that stage, code quality here, code quality disabled. And the reason we're doing branches and tags is because we don't want to run a lot of these things all the time. License management, same thing. So it's pretty repetitive until we get down to starting to go into production on the CD pipeline. So we can see here, review apps, we explicitly call out that if we are using a reference that is master, in other words, our main branch, don't do a review app because we're at that point going to be pushing to production. So we don't need to set up a review app, or if a review app disabled is set. As we look through a little bit more, we start seeing things like staging, which is typically a continuous delivery piece of it, or canary builds, and as well as the production template. And you can see that those all have only do it on master. And because we have a Kubernetes requirement for certain parts of this, do it if Kubernetes exists. And again, you can see that there's a lot of variables that you can set, except if, right, to change the behavior of the pipeline as it's going. So this is not a predefined step-by-step pipeline in that sense. It will look at the inputs and it will adapt how it behaves based on that. As a matter of fact, this single pipeline definition is actually how we do both the CI pipeline for building and testing and verifying, as well as once it's gone through approval and been merged, then it kicks off the CD pipeline for the delivery, which is the packaging and deploying and validating. And that is a single definition here. The pipeline behaves differently based on how it's being used. So let's go from that then to a discussion about the built-in capability. So if we say new file, so there's a built-in capability in GitLab called auto DevOps. Now that is a best practice pipeline that we have put together. It is still defined in the GitLab CI YAML file. When we actually have that here as a template, again, that's the one that we've been looking at. And this is a pipeline which does all of these things automatically, sets them up for you. And so the idea is you put your code in the beginning, and at the end, you have a production system. Now, what that means is the pipeline has to be adaptable and has to look at the code and understand what code it's working with, understand how to build it, how to package it, how to test it, how to deploy it. And so the pipeline is pretty smart about doing that, and it does it automatically so that, again, literally you can put your code in the repository and auto DevOps, if it's on, it will pick it up and it will do all the work to test it and eventually put it into a review app. And then from there into production. Once it's been approved, it will go through the cycle again. So I actually have some of those pipelines that have been run, so we can actually see that. Here, for example, is one that was pushed to a branch. We'll actually look at this one. And so when it's being pushed to a branch that is not the default branch, it will do the builds, do a series of tests, Again, no definition of what the code is, what the language is, or anything. That's all defined or figured out by the pipeline. This test is for unit tests from the developers, so it looks at that as well and picks those up and does them. There's a review app where it puts together dynamically a staging environment per commit, per person, per branch. So what this means is everybody can actually interact with their application rather than wait right away to make sure that they're doing good quality code and solving the problem. That makes it available to stakeholders as well. And this is much better than waiting until that staging environment all the way at the end, where it only gets looked at by the first time by the business and everyone else, and possibly has to go all the way back to the beginning in development. So this is very valuable. We also do some more testing based off of having a live app, like dynamic testing and performance testing. And that's it. That's the CI pipeline. So you'll notice we've pushed left the security scanning, as well as the staging and interaction with the live running app. So we're going to go back now to that list of pipelines, and we see that this pipeline was pushed to master. So at this point, the results were looked at from this pipeline, from the first pipeline. Someone said, yep, this looks good, I'm going to merge it. That merge kicked off, and it created this pipeline. Again, this is the same single file, build and all the same tests, because we want to make sure that that has not changed. Then it goes to a staging environment, a late stage staging environment, so that people can validate, do a final validation before it has a manual rollout. And we see here that this is an incremental manual rollout, and it looks like they actually went through all the steps, 10%, 25, 50, and then 100, and then performance testing at the end of all of that. So that's really neat. We got a pipeline that can detect what it needs to do and then do it. We've got a pipeline that's capable of changing how it behaves based on the inputs that it's receiving. Now, I wanted to point out one final part of this, which was the composability of that pipeline, which is we have all of this great capability and definition of the different stages in the pipeline, and customers want to use it, and we want customers to use it, and we want to be able to set up a pipeline where it has the parts that you need and has information in it that is best practice, hardened and tested and validated, etc. And so we've done that. So code quality, for example, a lot of them are at the end, the security scanning. There are templates here for lots of different things, but that also includes the security scanning, the DAST, the dependency scanning, license management, and SAST, which are all parts of that Auto DevOps pipeline. So if we look at one of those components, we can see that it starts just basically with the static application security testing stage and has all the definition, and someone can take that and drop that into their pipeline definition, or they can extend this one and they're off to the races with a tried and true tested SAST stage for their pipeline. Error visibility and transparency of the system. So in Git Lab, the errors are surfaced very transparently, just like in most CI and CD systems. However, we have everything linked automatically, so you can get from one error to another deep piece of detail to solve the problem. So here we're looking at a set of pipelines that have been run for the Spring App project. We can see that I had a failure here that bubbles up as a failed in the summary, and I can see in the small pipeline that, wow, we didn't even get past build. If I want, I can get to the details of that. I'll do that in another window. And that gives me direct access right to the job logs, all the detail about what happened, so that I can start analyzing it and understanding what's going on. I could also retry it from here and see if that fixes the problem if we have a transient situation, like using trying to access something externally that doesn't exist or isn't responding. Likewise, when I look at the merge request that this was kicked off from, problem also bubbles up into the merge request, so that that is visible to all of the stakeholders who are watching this merge request. Now if we go back to the pipelines page here, I can see also that there are some of these orange ones. These are tests that passed with warning, so there were problems, but they continued to pass. So oftentimes this is some sort of test failure, but the job is not set to fail the pipeline, and that's intentional when that happens. So we can see various different types, and if I have one that passes, but still there were test failures, that is identified here. Another piece of the visibility is not just the pipeline status in the MR, but goes beyond that. One is having a review app set up from each pipeline run, so that this one is not running right now, but so that I can actually see the app, the changes that I have made. But then we also do all of this scanning and testing and validation during our pipeline run. And so that comes back to the MR so that we can see things like, how does my code quality look? I've improved a little bit, that's good. How about the performance information? Because we did some performance testing. Here's the big one that's really valuable, is what were the results of all those security scans? Well, I can see that a lot of vulnerabilities were found here. This is a sample project. But I can also interact directly with those vulnerabilities and take action. So I can see information about them, I can dismiss them or create the issue from them so that we can track fixing them. I also have access to the point in my file where that triggered that vulnerability so that I can work towards solving that in as quick a way as possible. This is what one that's dismissed looks like, and we have that for all the different vulnerabilities. Now, we also do license scanning and that information, so there's no new licenses found here, but I can get a full report of the licenses that were used in this project. And from that I can see there's quite a few, and some of them are ones that I have flagged in the project policy as not okay to use. So those will need to be dealt with. But better I know that now than when we're about to release. So that's visibility of a lot of great information that helps to make good decisions about getting good software out quickly. We've also got the environments, which is a collection of the different places where the product is installed, where the application is installed for this project. And I can see from there that I can also see the running application, and I can get to the monitoring information that happens, that gets set up automatically with each application deployment. And that information gets pulled in from our Ingress proxy. It also gets pulled in from the hardware that it's sitting on, or the virtual hardware, the infrastructure, Kubernetes in this case. And we can also see that there are these little rockets down here, which are really handy because these are indicating where deploys happened, so that I can look at the changes in behavior of my application, like the memory usage and the core usage, and then correlate those directly to when I actually changed my application. So you see that there's a commit SHA down here, so I can actually jump to that commit SHA and get the details about what was changed and who changed it. Really useful set of information. We also have information on the project level, or sorry, at the group level, about all the contributors to the project and how they've been contributing, how many merge requests and issues they have done. And insights, what we call Git Lab Insights, which gives us a flash of information about the number of bugs that we're tracking and the severity of them, by priority and by severity. We can also look at the merge requests that have gone in so that we can understand, as a release gets closer and closer to production, what is the quality, what is the tailing indicators about what might happen. Alongside of that, we have cycle analytics, which watches what everybody does and summarizes how we do overall as a team as we move through the different cycle. So less than a minute for issues to be created from ideas, 2 days to plan, that means getting them onto the schedule, 26 minutes to get testing done, on average 14 minutes to do reviews, 3 minutes for staging, 2 days for production to get it to production. So this gives us a sense of how our team operates as a whole, and how we are moving and what areas we could tune in. We also have, at the group level, the security dashboard that gives a high-level view of the aggregate information of security vulnerabilities in the products that are part of this group. So for example, how many criticals, highs, mediums, and low vulnerabilities. We have a graph. We can slice and dice the data, maybe saying we only want to see the medium and critical ones, or and high ones, so only the high stuff. We can look at different report type information, DAST versus SAST versus container scanning, and pick particular projects that we want to see. As well, right below are those vulnerabilities that you can get directly to, and you can pull up information about them and take action on them, just as you could if you were in the development phase. And this is something we view that typically security administrators will be using to keep an overall view of the quality of the security of the products that are coming out of the teams. There's also an operational dashboard, which gives which everyone can customize to the projects that they want to watch, which says, here's a project, here's what's happening in it, how many alerts it has, look at that, I've got a blocked pipeline I should probably go deal with, etc. So this is really valuable to get an overall view of everything going on that is of the things that are marching towards production, towards release.
Pipelines have different algorithms or flows to them. And that difference is based on what language is being worked with, what technology is being developed, and where it's going to end up. Git Lab makes it easy to pick different algorithms or flows for your pipeline. Here we are in the repository. If we go to set up a new file, GitLab will make available to us our templates. There's lots of different types of templates. For example, what files to ignore from Git, Docker files, and how to set up your Docker image, license files, and then what we call the .gitlab-ci.yaml file, which is how we define our pipelines. Selecting that, I see that there's lots of different types of pipelines available. And these different pipelines come with different algorithms built in. For example, if I wanted to work on Android and deploy it into Fastlane, here's the code for the pipeline that has that behavior built in. So the algorithm is work in my environment setup, then do build, then test, then deploy. Go to internal, then alpha testing, beta, and then production. Similarly, we have an auto DevOps pipeline, which is the one we run by default. And the auto DevOps pipeline looks at the code, and based on the code that's being written, determines how to build it and deploy it, and then how to get it out into ultimately a production system so that it can be used. We also have built-in pipeline for doing such things as working with OpenShift. Again, just looking at several different examples here. A different algorithm: build, test, deploy, review, staging, production, cleanup. I want to point out, though, it's not just the stages that are defined, in other words, the overall flow, but also what happens in those stages is also predefined, how to interact with the different technologies that are involved. Should somebody want to customize any of these, they merely need to pull it down, for example, working with serverless, and then edit what they want so that it fits their needs specifically, whether that's overall flow or specific behavior within a stage or a job.
GitLab's great for remote teams to collaborate. No matter where they are or what teams they're part of, if they're working on something together, GitLab will facilitate them. We're looking, for example, at an issue that was opened several months ago by the PM, Fabio, and it's a particular problem that we needed to solve. And we're going to look at this from the perspective of how the teams are using to collaborate on it. So there's the discussion area in the top where we can put in pictures and videos and animated GIFs. Our design team looked at some ways to solve this problem after discussing it, and that information bubbled up to the top in the description area. But what's great is this becomes the area of where we are in the discussion. But we can also see that when we get past that, we get to the point where there's discussion, the actual history of discussion that happened. So before we get there, we can see here all of the related work that came out of this and what stage they are in, all the related merge requests that are actually solving this problem. And here we get to the discussion part, and I'm going to have it just show us the comments, not all of the changes in status and whatnot. And there's a discussion between our PMs and our user experience folks. Our engineering gets involved, and these folks are all over the world, including myself as a technical marketer because I found the problem originally. Our product marketing manager for this area is also giving her input. And our operations folks in the background who are going to have to support this. Security folks looking at how this is going to affect, if there's anything that needs to be concerned there. The ability to put in, again, screenshots that can express the idea that we're going towards is in the tool. And so you can see that this was a lot of discussion. There was thumbs upping, smiles and whatnot. And so we're having a lively discussion as you would in a meeting in person, actually much more efficiently because this is asynchronous. Everyone around the world working on this problem together and communicating what their thoughts are on it. Even when we decide that we reached a point where we need to back up a little bit, that's possible, and that continues through, as well as the fact that all of this is captured. So anyone who needs the history of how something got to where it is can always come back to this and see all of those details. Now, this actually got to a point way at the end here where the problem statement and the idea about what we might do here is approved, and then we started working towards the actual implementation of the solution. We can see that that this MR here is linked, which is the work that was started to actually solve this or some parts of this. And there's a definition here and video. And so the conversation for the solution picks up here. And we can track that. Git Lab tracks when the work is done, in what branch, what deployments happen. And you can see here the last one was a fail. So we have to circle back and figure that out. But it telling us where it is going to deploy it to, which is a review application, so we can see the changes in action. And all the people involved. And as a result with this one, as they encountered the problem, there was more discussion, which took place around solving the problems that were encountered. Even code review and discussion. And then eventually we identified that this was had some unexpected problems that we weren't ready to solve. They weren't able to solve in time for a release, and so it got bounced to a later release. But all of that history has been tracked, and this team will continue to pick up on this issue and from here and get it into the next release. So that is an example of using GitLab as a tool for collaboration across multiple remote folks and different teams to solve a problem and get it eventually into production. We're going to take a look at the audit and log tracking of a delivery to production. So here we are looking at the environments of our Spring app, and from there I can see immediately already what was rolled out when. So this commit was rolled out 34 minutes ago. By whom? By myself. I'm Workshop 1 user. I can look from here and see the actual running code in production. I can also jump over directly to our built-in monitoring, which automatically on installation or on delivery provides monitoring and starts tracking for the app the various forms of behavior of the app, latency, error rate, throughput, as well as the performance metrics on the infrastructure that it's running on. And I can see here that there is some variability. Importantly as well, from a tracking perspective, is this little rocket, which gives us the point at which we deployed so that we can correlate the behavior that we're monitoring versus the changes that we've made in the app. So here I can see that I deployed commit 77B 5218C. So remember 5218C. And that is actually what is showing here. So, right, really easy to get to. However, I can see more than that. If we go to the environment itself, I can actually see the whole history of deployments to that environment all the way from the beginning. All these different commits, who did them, how much rollout there was at that point in time, when it was. So that's pretty fantastic. But let me go ahead and focus right now on the last one because that's what's actually active. I can roll back to any previous installation, deployment, but let's, before we do that, go take a look at this last commit because we don't know yet quite that that's what's causing the problem, the potential problem. So again, we're jumping backwards from an environment that was delivered to the work that was done to deliver it, back to the code change. This is where we are right now. I'm looking at the commit, which has the code change that was made. I can see who did it and when. I can see the pipeline that actually deployed it. So I could actually go into this and look at these details as well because that actual delivery process was logged fully as well. So we can see all of that is captured here in case I need, including the artifacts. I can also go further back than this. So this commit was created and it was delivered by this pipeline. But let's look at the merge request. Now, if you recall, the merge request is where GitLab stores centrally everything about the change, the solution, the change to the problem for the problem solution. So here we have the branch that was worked on, the pipeline that was created in CI to make sure that we had a good change, the review app that we can look at, which was the changes in a running app before we pushed to production, so personal staging environment. If there were approvals that were done, those would have been identified. We also captured the information about the security scans and what vulnerabilities were found and dismissed. The license information that was found, do we have any that aren't compliant? The user and when they actually released this, did the merge, and the pipelines that then resulted from that merge. These are the continuous delivery pipelines. Again, this is the one that deployed it into production, the one that we were looking at in production. And again, here we are, 5218C. So all of that information is cross-linked and tracked, including the results of those deployments and where I can get to them, and all the changes that went in as well. So we saw that again earlier. All this information is here in the merge request. So we've gone backwards from an environment to the code change that was pushed out to the work that was done to make that, to decide on and test that code change. And then finally from here, we can make that single final step back. This closes a particular issue that we started, a problem statement we started that started this whole thing, what needs to be fixed and why. And that is also forward linked, of course. So there you have it, from the end result all the way back to the beginning, full traceability and auditability, end to end, out of the box.